Hey all. So, please do not forget that Monday will be our first midterm. And for some of us, the midterm will take place here in this room, but this room isn't big enough for everybody who's taking the class. So, we have 730 seats here, and therefore we have a second room, 2050 Valley Life Sciences Building. So, if you are in labs 11 to 30, please come here for your midterm on Monday. And if you're in labs 31 to 42, please go to Valley Life Sciences Building, room 2050, and there will be TAs there to take care of you. Please try to arrive a little bit early, like 1 o'clock sharp if you can, so that we can get the exam started on time. And when you come in, please try to sit, when you sit down, since most of the seats are going to be taken, try to make room for people. If you come in early, try to sit near the center of the row rather than blocking other people and making them walk over you. The exam will be open book and open notes. You can bring whatever you want that is on paper. It is closed electronics, and I mean very closed electronics. You're not allowed to have any electronics on your person at all during the exam. So no phones, no laptops, no PDAs, no anything unless you have like a dumb watch. Please, if you can, leave your electronics at home. You leave your cell phone at home. But if you can't, then put them on the stage at the front of the room before you sit down with your exam. And if you are caught with even a cell phone on your person during the exam, you get a 0 on the exam. And if your phone is at the front of the room and it rings during the exam, you lose 1 point. The exam itself will cover the material in lectures 1 through 12, as well as everything we've learned in the homeworks and labs and maybe discussion sections. For those of you who are wondering, this lecture right now is going to be lecture 12 for the first hour and lecture 13 for the second hour. So I'm going to talk about abstract classes for an hour. That will be covered on the exam. Then I'm going to talk about Java packages, which aren't really a test-worthy topic anyway. They're just something that's going to be important to you when you do your homeworks and projects. So that will not be on midterm 1, though it's eligible for midterm 2. If you are in the disabled students program and you've asked for extra time, we're trying to work things out with the university proctoring service. There are 14 of you in the class whose forms say that you get extra time, so it's taking a little while to set that all up. Right now, what the proctoring service thinks is going to be the deal is that they'll be able to take one set of students in the DSP program starting at 12:30, meaning you start half an hour early, and a second set starting at about 1:45. And we don't know who's going to be in which group yet. To figure that out, once I get more information from the program people, I'm going to post something to both the class webpage and Piazza, so please look out for that. Also, I want to remind you that Project 1 is due this Saturday night at midnight, so please be on time for that as well. All right, before I go into the lecture, are there any classes about the exam? Mm-hmm. Yeah. So if you want to know how the lectures are numbered, go look at the class webpage, and it's based on the lecture notes. So the lecture notes for 1 through 12 are covered. Other questions? Mm-hmm. Right. So 1 minute after 11:59 on Saturday night. So 11:59 p.m. Saturday night plus 1 minute. The border between Saturday and Sunday. That is when the project is due. Question back there. No, you don't have to submit test.java. We will have our own copy of test.java that we use for the autograder. Java has something called an abstract class whose sole purpose in life is to be extended by other classes. And so an abstract class is a class you can't actually construct an object of that class. You have to make a subclass of that class, and then you can construct objects of that subclass. So here's an example. I'm going to use this to provide a general interface for lists. But it's not any particular kind of list. It's just defining the interface that I want all lists to use. And so I'm going to say that, well, every list ought to have a size field. And I'm going to give it a special kind of, I'm going to give it protection so that it's readable in list and all of its subclasses. And I'm going to say that every kind of list has to have a length method that tells you the length of the list. And which always returns the size. And I'm going to say that every kind of list has to have an insert front method, so you can always insert something at the front of the list. And I could add more method prototypes like that, but I'll stop here for now. Now, this method here, insert front, is interesting because I didn't provide an implementation for it. I wrote out the prototype of the method and then just stopped with a semicolon, and I declared it abstract. So what is an abstract method? It's a method that I don't actually provide an implementation for. So what good is it? Well, it ensures that whenever I create a subclass of list, that subclass is going to have an insert front method. I don't know how it's going to be implemented yet, because I don't know how any particular kind of list is going to be implemented, but it has to have an insert front. Now, abstract classes do not allow you to create objects directly. I cannot create a list object that's just a list object. But I can declare a variable of type list. So if I say list, my list in some other class, let me draw a line here just to remind you, we're now in a completely different method in a completely different class. I can declare a variable of type my list, and this compiles. The compiler is happy to give you a variable that can hold any list, even though you cannot construct a list object. And if you try to construct a list object, say that, well, you can't do it because it's an abstract class and they don't make their own objects. So this will give you a compile time error. The compiler will not let you compile this. But abstract classes can be extended just like ordinary classes can, and the subclasses are usually not abstract. They can be, but usually we branch off of list to make a bunch of particular kinds of lists that have implementations. Now, remember, we've got this abstract method insert front. And an abstract method is a method that lacks an implementation. But one of the main purposes of having an abstract method is to ensure that every subclass of list that isn't abstract will implement that method. So let's define a subclass of list that we're actually going to implement. So we will go back to our favorite slist class. And it's pretty much the same old slist class we know and love, except now we are extending list. And that means we are promising that slist will have a particular kind of interface that might be shared by other kinds of lists like dlists. And of course, inheritance works just like it works in non-abstract classes. So the slist class will inherit the size field that we declared up in the list class. But we can add new fields as usual. So I'm going to need a head field to actually implement an slist. So I will add that here. And that's it for my fields. Now, got to think about methods. Well, we've got a method inherited already because the list class did provide a complete implementation of the length method. And so that's inherited here, and it works. We also inherit a prototype. We inherit the prototype of the insert front class. And now, because slist is not an abstract class, now we have to provide an implementation for insert front. And so, this being inheritance, one of the rules is I have to copy the signature from the superclass to the subclass. So I'm effectively overriding an abstract method here. And now I'm going to provide an actual implementation for this method. The standard implementation will do. All right, so that's how you write a real, non-abstract, concrete class that inherits from an abstract class. And now you can create slist objects. You can't create list objects, but you can create slist objects, because slist is not abstract. To do this, to be able to write this slist class that inherits from list, I had to provide an implementation of insert front, and if I hadn't done so, the compiler would have complained and given me another compile time error. So there are a couple of things a non-abstract class can never do. One is a non-abstract class can never contain an abstract method. If you want to be able to create slist objects, you'd better be able to call all the methods of your class on those slist objects, so you can't have an abstract method. And the other thing they can never do is inherit an abstract method without providing an implementation. Since you cannot create a list object, it's okay to provide a method interface that doesn't actually have an implementation, because you're never going to have a list object to implement it on. But you can create slist objects, and therefore there has to be an implementation of the insert front method, because someone might call insert front on an slist object. So now that we've done that, here are some things that are acceptable to do with that class. First of all, I cannot construct a list object, but I can construct an slist object. And every slist is a list. Therefore, I can assign an slist object to a list variable. And so this compiles and runs no problem. Another thing I can do is, now that I've got that slist object, I can actually call insert front on it. And I can call insert front on a variable whose static type is list. And that compiles and runs too. And so the thing to understand about the second line of code is that mylist has type list. When Java compiles this, it asks itself, am I sure that mylist is going to have an insert front method? Well, fortunately, every list is guaranteed to have an insert front method. So what that abstract method did, the reason why I had an abstract method called insertFront in the list class, is so that I can write lines of code like mylist.insertFront that Java is happy with, because Java knows that any object of type list has to have an insertFront method. And so this can compile. And then when you actually run it, at runtime, Java does dynamic method lookup. It finds out that mylist is an slist, and so it runs the version of insertFront that works on the slist class. Any questions about this so far? Are you allowed to have a constructor for what? Oh, no. So abstract... Wait a sec. Let me think about this a sec. I haven't thought about this in a long time. I think you can. I think you can have a constructor for the abstract class because the subclass calls it automatically. But I would have to look that up to be sure, honestly. It's been a while. Yes? An abstract class can extend another abstract class, yes. The only thing that can't happen is you can't have an abstract class extending from a non-abstract class. That's not allowed. Oh, so if I wrote something like mylist.head and tried to do something with that. So if we go back and look at the head has protection, which means it's only readable within the the slist class. Oh, sorry, it's declared an slist, right. So right. So the answer is no. Mylist, not every list, is guaranteed to have a head field. So Java will not compile this. Right. In this case, it has nothing to do with the protection. But if head had been defined in the list class instead of the slist class, then the protection would matter. And then it would depend, where is this line of code? Is this line of code inside the list class or outside the list class? Mm-hmm. Yes, an abstract class does not have to have an abstract method. An abstract class doesn't have to have any methods, actually. So that's fine. Mm-hmm. Say that louder, please. The parameters of the method. When you are overriding a method, the rule is you have to write exactly the same signature. Overriding just doesn't work in Java if you try to change the signature at all. If you change the parameters, some things will still work, but you won't have overriding, and that's usually a bad thing. Question here. Yes. So the question is, all right, so this doesn't work because not every list has a head field. Let's suppose we cast the mylist. So now it has static type slist instead of static type list, and then we refer to the head field. Well, yeah, that can work. So that now every slist does have a head field. So Java is much happier with this line of code. And now it's just a matter of since head is protected, now it's just a matter of whether this line of code is inside or outside slist or one of its subclasses. Mm-hmm. Why would its dynamic type be different from its static type? Because we want to be able to write programs that work with any kind of list. So, I'll talk about this more in a minute, but I want to have a program that, say, sorts every kind of list, not just one kind of list. And therefore, I'm going to use static type list and write my code so that it sorts static type list. And then when you actually run the program, it's going to get some specific kind of list to sort, and that'll be the dynamic type. Mm-hmm. Right. So a method that's declared as abstract cannot have a body. It's not allowed, and if you try, the compiler will complain and won't compile your code. All right, so what are abstract classes good for? Oh, sure, one more question. When it compiles, so we're talking about this, and you're saying, why won't it compile? Won't the compiler look up the static type first? So the compiler does look up the static type of mylist and sees that it's list, but we didn't define the head field in list. We defined it in slist. There it is. Okay. All right, so what are abstract classes good for? To provide an interface that you know you can count on. So I'm going to put this in a box because it's the main point. This is what abstract classes are all about. They're there to let you officially define an interface before you write any code that actually does anything. And this is an interface that many different classes can share, meaning, in this case, many different types of lists can all use the same interface. And then once you have that interface established, you can go off and write a program that sorts lists or other utilities that do things with lists. And you can go write an application that uses lists and uses that list sorter. All of this without ever knowing how that list is going to be implemented or which kind of list you're going to use. And so what that essentially means is that the list class I defined earlier, the abstract list class, even though this does not have an implementation, this is an abstract data type. So remember the definition of abstract data type, remember the definition of interface. An interface means you have a bunch of public method prototypes that you know you can use to manipulate a class, and you have English language explanations of what the behavior of those should be. And the funny thing is, once you have that interface established, you can write out an abstract data type even though you don't have an implementation of that abstract data type yet. You just know this is how it's going to work. And the reason why you'd want to do this is, for instance, if you and your project partner are trying to divide up a project, one of you is going to write the lists, one of you is going to write the code that uses the lists. You agree on an interface first, then you can each go off to your separate homes and write your separate pieces separately, and then bring them together, and they'll work together because they use the same interface. And so here's another example or another schematic to show you how this works. I'm going to have 3 different pieces here, but here's the first 2 pieces. The bottom level thing that you're building on is that you have a list abstract data type. And along with that list abstract data type, you may have a bunch of different implementations of lists, all of which you're going to write tomorrow. Then you have other programs that call the methods in the interface of that abstract data type, like, for instance, a list sorter, whose job is to take a list and sort it. And part of the point here is that when you do this, one list sorter can sort every kind of list. And to make that happen, the list sorter will also have an interface of its own that allow applications to call the list sorter. And the list sorter interface will look something like this. So there's code at the end. So here I've got this list sort method in my list sorter application, or in my list sorter class. And the important thing here is that it takes a parameter of type list. It takes a parameter that is an abstract class. So I know I can pass this thing any kind of list, and as long as it implements the list interface, I can sort it, even though I don't know how it's implemented. And that list could be any of dozens of subclasses of list. So if I want to use an S list or a D list or a tail list, I can do that. And maybe tomorrow I wake up and decide, well, I really need a list that times how much time my application is spending doing list operations, so I can see where I can make my code faster. So let's tomorrow wake up and invent a timed list that uses the list interface, but also records all the time spent doing list operations. And maybe the next day I decide that, well, I want to use my list data structure in automatic teller machines. And the thing about automatic teller machines is that if the power goes out while you're doing a transaction, you need to know for sure what was happening at the moment the power went out and whether or not you actually gave somebody money or not, so that you keep their bank account balance correct even if the power goes out while they're using the ATM. So to do that, what is often done in computer science is that you have data structures that are designed to store every operation onto a disk or onto a flash drive immediately, the moment they happen, so you know whether or not you handed out dollars just before the power went out. And so that means you need to implement another kind of list that records every list operation the instant it happens on the disk. And so we can do that, and we can plug that into our application tomorrow, and nothing else changes. You might have written your list sorter years before transaction lists were ever thought of, but your list sorter will still sort it. Now, on top of that, there's an application that uses all these lists, like the automatic teller machine. And an important thing to understand here is that the application that has lists to sort and is calling the list sorter, be it an automatic teller machine or whatever else, the application is the one that gets to decide what kind of lists it's going to use. The list sorter does not decide what lists the application uses. It just obediently sorts its lists. And so if you had an automatic teller machine that didn't log its transactions to disk, and you decide tomorrow that you need one, all you have to do is change the list class, and everything else will work. Any questions about that? Mm-hmm. What is your question about the object class? Yeah, okay, that's true. I think I said something wrong before. I think I said that abstract classes can't inherit non-abstract classes. I think that's incorrect. I think they can. So, yeah, and everything inherits from the object class, including abstract classes. Other questions? Mm-hmm. So applications would be, well, the Sobel program and the Blur program that you're doing in Project 1 are applications. An automatic teller machine is an application. Your phone, the software that runs on the phone that does things, is really an application. So that's what I have in mind when I talk about applications. As opposed to, say, a list sorter by itself isn't an application because you probably never use a computer just to sort a list. List sorting is kind of something that's done as part of some bigger purpose, like calling someone on the phone. Mm-hmm. Uh-huh. So when you pass in something to change its static type, is that what you said? Right. Mm-hmm. That's exactly what it did is. The question is, when I do this, does that change the static type? Well, MyList itself hasn't changed, but what has changed is this expression, the whole expression in parentheses, has a static type. It's really in Java, it's expressions that have a static type. So the static type of MyList is list, but the static type of this whole expression now is slist. No, because the static type of MyList by itself never changes. Yeah, so this expression has static type slist, but MyList itself will always have static. When it's all by itself, it will always have static type list. When you cast something, you're not really changing the thing that you're casting. What you're doing is you're creating an expression that has a different type for that line of code. All right. Java has an interface keyword, which refers to something quite different than what I've been calling interfaces up till now, and therefore that's a bit confusing, even though they're sort of related. So from now on, when I just use the word interface by itself, I mean the same thing I've meant all semester, which is the standard computer science definition of interface, which is the public fields, method prototypes, and behaviors of your public methods. So this is the same thing I defined like 4 lectures ago. But when I say Java interface, then I'm referring to something completely different, which is Java's interface keyword. And a Java interface is a special kind of abstract class. But there are 2 differences between a Java interface and an abstract class. So the first one is that in Java, a class can inherit from only one class. You just can't say that a class extends 2 different classes in Java. But it can implement, which basically means inherit from, as many Java interfaces as you like. So, in a sense, Java interfaces are kind of more powerful than abstract classes because you can inherit several of them. There is a trade-off for that, which is that Java interfaces are very limited. So they cannot do the following things. They cannot implement any methods at all. And nor can they include any fields except for static final constants. So if they can't do that, what can they do? They can include method prototypes, and they can include constants. And those have to be static final constants. So before I say more about why this is the way it is, I want to give a code example, and then I'll come back and talk about why we have these restrictions. So what I'm going to do is write in a Java interface now. So here's a simple example of one. So here's a public interface. It's pretty much like a class, except it's not. And since it's public, just as if it were a class, it has to go in a file called nukeable.java. And inside there, I'm going to put prototypes. I'll just do one for now. And so what this is doing is it is providing an interface in the usual sense of the word, meaning anything that inherits nukeable is going to have a method called nuke with that prototype. And by the way, this is an abstract method, but I didn't have to use the abstract keyword. I could have used the abstract keyword. If you want to write public void abstract nuke here, or public abstract void nuke, that's fine. But you don't have to write abstract because in a Java interface, you can only have abstract methods. You can't have a non-abstract method. So you can leave out the abstract keyword. It's still going to be abstract. Here's a second example of an interface that you should know about because you'll have to use it from time to time. This is one you don't have to write yourself because it's already in the Java libraries. Specifically, it's in java.lang, the standard library. You don't even have to import yourself. And anything that implements the comparable interface will have a method called compareTo, whose job is to compare two of these objects with each other. And so now we have these interfaces. I can write classes that implement these interfaces, and a class can implement as many interfaces as it wants, and it can also at the same time inherit from one subclass as well, from one superclass as well. So to illustrate the syntax, how you write that out, I'm going to define a class slist again. I'm going to modify the previous slist class that I've already written out. It's still going to extend the list class. So we still have one superclass list, but it's also going to implement some interfaces. And when you want to do that, there's a different Java keyword. You don't say extends, you say implements. And if you want to implement more than one interface, you list them all together, separated by commas. And then all the previous stuff that I already wrote out, we'll keep that. But we'll add some new stuff, because I have just implemented these interfaces. And what that means is that now, since slist is not an abstract class, I'm going to have to implement those two methods, nuke and compare to. So let's do that. Got to copy the prototype here. So I'm just going to have nuke be a method that resets the list to an empty list. So that's pretty easy to do. Set the head to null, set the size to 0. And then I also have to implement this other method, compare to. So again, copy the signature. I'm not going to write out a full implementation of this method, but I'm going to tell you what the Java convention is, because you'll be using it this semester. So again, Java has this convention that if you want to have two objects that can be compared and sorted with Java standard libraries, they should implement comparable. And when you implement comparable, what you're doing is you're promising that your class will have a compare to method that works as follows. It returns a number that is less than 0 if and only if this S-list, or this comparable, is less than the other S-list O that's passed in as a parameter here. And it returns exactly 0 if the two are equal to each other, as defined by the equals method. And it returns a number that's greater than 0 if this comparable object is greater than the other comparable object, O, passed in as a parameter. Now, there's nothing forcing you to use this convention, but if you mess up and you don't implement this convention correctly, then things like the Java built-in sorting methods aren't going to sort your things correctly. Question? So there can be conflicts between an inherited interface or different inherited interfaces. And if it's an unresolvable conflict, then the compiler will give an error and say, I can't compile this. And you're going to learn all about that in your lab this week. Questions? Yeah. Can an abstract method be a private method? You know, that just wouldn't make any sense. I'm not sure if the compiler will complain, but if you have an abstract method, then there's no way to implement it in a subclass, so that just doesn't make sense. Mm-hmm. Well, you have to write, how do you compare if an object is less than another object? You have to write code yourself that makes sense. So you have to decide, what does it mean for one list to be less than another? What's that? Yeah. Just like you have to write your own dot equals that makes sense for your particular kind of object, you have to write your own compare to that makes sense for your own particular kind of object. And if there isn't one that makes sense, then don't implement it. Mm-hmm. Yes, we'll do that. Can an interface implement another interface? I'll show you how to do that in a minute, but let me finish the questions first. Yeah? Do you have to implement all the abstract methods or what? You have to implement every abstract method you inherit or implement, no exceptions. Does that answer your question? I'm sorry, can you speak a little louder, please? Yeah, there will be a compiler error if there's even a single abstract class, if there's even one abstract method in any of the interfaces you're implementing or the superclass you're inheriting, then there's a compiler error if you don't implement it. Yes? if one of the methods, sorry, say that again? Uh-huh. Ah, yes, yes. So sometimes you will inherit a method implementation from a superclass, and you will inherit a method prototype that matches it from an interface. In that case, if the two match, then you're good. You don't have to re-implement or override the method that you inherited. As long as it matches the interface you're inheriting, that's good enough. Mm-hmm. All right, so I want to say a few words about this difference between superclasses and Java interfaces. The whole idea here is that many programming languages provide you with something called multiple inheritance. Multiple inheritance means that you inherit from several different superclasses. But so it's kind of like that book, Heather Has Two Mommies, except that Heather ++ can have 5 mommies. There are problems with it, though. There are some big problems that come up. For instance, suppose that you have 2 different superclasses that each declare a field with the same name. What do? There are all kinds of problems like that can come up, where you have conflicts between something you're inheriting from one superclass and something you're inheriting from another superclass. And so Java, instead of dealing with the hard problems, what they did is they took sort of an easy way out, which is easier to implement. And that idea is we let you inherit from only one superclass, but from many Java interfaces, and then we restrict Java interfaces in such a way that the conflicts that would normally arise can't happen. And that kind of gives you a messy and confusing language definition, but it solves a lot of problems in terms of ambiguity of inheriting the same things from different superclasses. And also a lot of the most difficult problems in bugs and implementation of the C++ language are a result of multiple inheritance. Multiple inheritance in C++ can do a lot of crazy things that can drive you nuts. So the Java designers decided they just didn't want to have to deal with the problems that C++ has with multiple inheritance. So they made things work this way. So one thing that's interesting about interfaces, Java interfaces, is that you can define a variable whose type is a Java interface, just the same way you can for an abstract class. So for instance, in some other class or in some other method, I can define a variable n of type nukable, static type nukable. And since every S-list implements nukable, I can construct a new S-list object, and I can assign it to a variable of type nukable. And I can also assign it to a variable of type comparable. So I could say comparable C equals new S-list. I want to do something slightly more interesting. I want to assign n to C. But if I want to do that, I need a cast. So this is perfectly good code. It compiles, it runs without an error, because n is going to be an S-list, which does implement comparable. But I did have to have a cast to reassure the compiler. And the reason I had to reassure the compiler is because not every nukable is a comparable. Once you say that something is a comparable, that gives you access to some libraries in Java that help you do things with comparables like sorting. In particular, the arrays class in java.util sorts arrays of comparable objects. And in the arrays class, the particular method that does that has this prototype. Again, this is in java.util .arrays. One thing you might be wondering here is, why is the parameter type object array? Why is it not type comparable array? The reason is for convenience. You might have an array of type object sitting around that you want to sort, and you might know that it's full of comparable objects, but you don't actually want to have to create a new array of type comparable. Well, Java is still happy to help you sort it, even though you declared the type to be more general than comparable. But when you call sort on the array, if there's any object in the array that is not a comparable, then Java will throw a runtime error when it tries to sort it. So you can call sort with an array of objects, but every one of those objects has to be a comparable or you get a runtime error. And coming back to the question the gentleman asked earlier, can interfaces inherit interfaces? Yes. You can have a subinterface that inherits one or even many superinterfaces. And so, for instance, I'll just give a trivial example here. I'm going to have an interface called nuke and compare, whose sole purpose is just to combine those other two interfaces I defined earlier. So there's the whole definition of the nuke and compare interface. So a couple of things to point out here. I'm using the extends keyword, not the implements keyword. This is one of the things about Java that's a little bit confusing. When a class wants to take advantage of a Java interface, it uses the implements keyword. But when an interface is inheriting another interface, we go back to the extends keyword, just like when a class is inheriting a class. So it's kind of confusing sometimes to try to remember, when do you use extends and when do you use implements. The second thing I'll point out is that in this example, all I needed was an open brace and a closed brace, because I'm not adding anything new that's not already in the nukeable interface and the comparable interface. So all this interface does is combine the two interfaces into one interface. But if I'd wanted to, I could have added new method declarations, new abstract methods in there, and maybe new constants as well. I just chose not to in this particular case. Questions about this? Yeah. That's a good question. So the question is, if an object is comparable, does it have to be do you have to be able to compare it to every other kind of comparable object? So usually the answer is no, but it's up to you how good a citizen you want to be. Like, if you want to be a really good citizen, then you'll write your compare method so that the first thing it does is checks whether O is the same type as this. And just say, give some random answer if it's not. But, usually, almost always, when you're doing something like calling the sort method, you're going to have an array in which every object has the same type, and it's just not going to matter. Mm-hmm. So the question is, what's a good example of where having sub-interfaces is useful? And yeah, I'm not sure I have a good example off the top of my head. I would have to think about that. I should try to come up with something, but nothing is coming to me right now. Sometimes, I mean, you can sort of imagine there's a family tree of lists with list at the top, and then maybe, there's a subset of timed lists. Like then there's a timed S list and a timed D list and a timed tail list, and so you might want timed list to be, say, a sub. I mean, this is really a subclass, not a subinterface, but imagine the similar idea applied to interfaces, where you just are defining an interface by which you're going to call all lists, and then you're defining an interface by which you're going to call all timed lists, and then you're calling an interface by which you call all timed transaction lists, and then you have like 20 different kinds of timed transaction lists. So you can have a piece of code that will sort any kind of timed transaction list, but not every kind of list, that kind of thing. That's the best I can do off the top of my head. Any other questions? Yeah. Implement both. That would be redundant. So if you have implemented nuke and compare, then implicitly you have implemented nukeable as well. So nukeable is a super interface if nuke and compare is a super interface. I don't know if Java would complain. It's one of those compiler tricks. Try it and find out. Mm-hmm. Oh, there isn't a reason. It's just the Java designers picked a choice which was probably the wrong choice and codified it in the language. Yeah. So constants, you can have two constants with the same name in two different super interfaces, yes. But if you want to refer to them, then you actually have to qualify them by putting the super interface name in front of them. So when you do the lab, I think that will answer some of these questions. But the short version is, it's not a real conflict because you're not actually storing two different fields of the same name in each object. You just have constants which are not stored in the object that have the same name, and that's easier to deal with than having two fields with the same name stored in an object. There were other questions, right? Over there. Java only knows how to compare objects that aren't primitive types if you write code that does it. So you write a compare-to method that does the right thing for your kind of object, and if you don't, Java can't sort them. All right, so that ends everything that's covered by midterm 1. Now we're starting to talk about a different subject, Java packages, which won't be eligible for coverage until midterm 2, although, as I said, packages don't really lend themselves to testing. Packages are something you're going to be using a lot when you write code, though, so you'll need this for homework 4, for instance. Java allows you to define packages, and a package is basically a collection of classes and maybe Java interfaces and maybe sub-packages that all go together and work together as a unit. And when I say they work together as a unit, part of what that means is that they trust each other. So usually they're all written by the same person for the same purpose, and therefore they're allowed to read and write each other's fields more so than outside classes would be. And so that gives you three benefits of having a package. One is that packages can have hidden classes that are only visible inside the package. So these hidden classes are used by the package. They're visible inside the package to other classes inside the package, but they're not visible or accessible to classes outside the package. And so a second advantage is that these classes can have fields and methods that are also visible inside the package only. And the third is that different packages can have classes with the same name. So for instance, I can have a package called java.awt.frame, and in fact I do have that class because it's part of the Java standard libraries. And I can write another class that's also called frame in a different package. Maybe I'll call it photo. And so it doesn't matter if somebody else happened to write a class with the same name as a class I wrote, you can still use them both in one program. Here are a couple of examples of packages. So you've already been using packages without really understanding what packages are. So for instance, everything in the Java standard libraries is in one package or another. Java.io is a package of input-output related classes in the standard library. And a second example, we're going to get you started using packages yourself and writing packages yourself with Homework 4. And Homework 4 will have a package called small-l-list. And inside that package, we will have dlist class and the dlist node class. And you will be adding some additional classes to that package. And the advantage of doing this is now dlist can read the fields of dlist node without everybody being able to read the fields of dlist node. So by the way, package names are hierarchical. That means you can have a package inside a package inside a package. So when you see something like java.awt.image.model, what that means is that there is a class in a file called model.class. And that file, model.class, gives you the bytecode. That can be found inside the image package. The image package can be found inside the AWT package. The AWT package can be found inside the Java package. So you can refer to any thing that's in a Java package by using what's called a fully qualified name. And I guess some things are more qualified than others, because system.out.println is pretty qualified, but we can qualify it even more. If you want the really, really long way of writing a println statement, this is the complete, you cannot confuse this with anything else, way of writing a println statement. So if you have, of course, the class system that you've been using all semester long. If you were foolish enough to write another class called system, and you wanted to use both classes called system, then the compiler gets confused because now you have two classes called system. Well, if we fully qualify the name and say java.lang.system, that unconfuses the compiler, so it finds the right system class. Now, another reason why you might need to use a fully qualified name is because you haven't imported the right package or the right class. And so we've been using this command import all semester without really knowing what it means. But what it does is it looks inside a package and finds a class there so that we can use it without referring to it by its full name. So if I write at the top of one of my programs, import java.io.file, what that does is, if I didn't have that line, I could have still used files, but I would have had to type java.io.file every single time. Now that I've imported it, I can just say file instead of saying java.io.file. And of course, I can go a step further and just import everything in java.io. Now, usually that's the convenient thing to do. Just import everything in java.io, and now you can use anything there. There are circumstances where you might not want to do that, namely, if there's a class in java.io that has the same name as another class you want to use. So you all know probably that every Java program automatically, whether you ask it to or not, imports java.lang. So you never have to import it explicitly. That's why you can just write system.out.println without writing java.lang.system.out.println. But again, if you make the mistake of importing multiple classes with the same name, then you have to go back to fully qualifying their names. Like, suppose that I import two different frame classes, and I want to use them both in the same program. Well, I wind up writing stuff like this. Because I've got two different frame classes, and Java needs to know which one is which. By the way, this photo.frame, this is in a file that's in a directory called photo, and the frame object itself is, or the frame class, is defined in a file called frame.class that somebody compiled. And if you have multiple levels of stuff, like if I write x.y.z.class with a capital C, then that class can be found in a file called class.class in a directory called x with a subdirectory called y with a subdirectory called z. So whenever you see in a Java program stuff referred to this way, there's an actual directory structure of files that corresponds to what you're writing that is how Java finds the classes that you want to use in your program. And so now you might ask, where does Java look for the photo directory? Where does Java look for the X directory? It looks in your class path. So for instance, a lot of you have noticed while trying to do Project 1 that when you run javac and you want to refer to classes that aren't right there in the directory, that you have to use some way of specifying the class path. And so a typical class path might be something like this. So the way to decode a class path is, first of all, Unix likes to use colons as separators. So that means that what we've got is a list of paths here where the Java compiler is supposed to look to try to find your classes, and those directories are separated by these colons. Those of you who are using Windows have probably found out you need to use semicolons instead of colons, because Windows just has to be different. And this dot here tells Java that it should be looking in the current directory first to find your classes. And if that doesn't work, then the second place it looks for your classes is in, say, a directory here. Maybe I have a directory called JRS classes where I just store all of the class files that I use on a regular basis. And then you can also have a .jar file. And a .jar file, you can essentially think of it a way as taking a bunch of class files that might be in different subdirectories and collapsing them down into a single convenient file. And when you do that, that's called a Java archive. And there are programs you can run that will take just a bunch of your class files, maybe in different packages, and just collapse them down into one convenient jar file. So this class path is how Java figures out where to look for your classes. And this isn't necessarily the only way to tell the Java compiler class path. I believe that with most versions of the compiler, there is a environment variable you can set, which in my current version is class path with all caps. So you set that in your Unix environment, and that way you don't have to type this every time. And by the way, the class path does not tell Java where to find the Java standard libraries. Those are in some secret location that the compiler knows, and you never have to specify it. Any questions about that? Mm-hmm. You sure? You can import packages, but you can't import like a field within a class. So you can't say import system.out. It would be nice if you could, because it'd be easier to print things, but you can't. Other question? Yeah. I don't know. Actually, Frame might be a Java interface. It still winds up with a .class file made of bytecode. So Java interfaces, they still compile down to .class files. They're not really different from classes in that regard. So we need to know how to build our own packages for some of the homeworks coming up. And so I'm going to do an slist and an slist node that are both in the same package called list, and that means they need to be in a directory called list. The Java compiler is very fussy about that. If you want to make a package called list, you have to put the files in a directory called list. So we're going to have in a directory called list a file called slist.java, and it needs to start with a package command, which is kind of redundant because it's in a directory called list, but Java wants that. And then you write out your class as usual. And now, in the same directory, I'm going to also write an slist node class in a different file. And this is going to be in a file called slistnode.java in the list directory. And since it's in the list package, this also has to start by saying package list. And then we will define the slist node class almost the same way as we have in the past. I did something interesting here, which is that I did not declare slistnode to be public. So if I didn't make it public, what is it? Well, it has what's called package protection, and so do all of the variables that I declared. So the class slistnode has package protection. So does the item field, the next field, and so for that matter do the head field and the size field of slist. I gave them all package protection. And package protection falls somewhere between private and protected. Now, you don't give something package protection by writing the word package. There is no package keyword in Java. Well, sorry, there is, but it does something else at the top, you can see. But package is not a keyword for choosing the amount of protection. If you want something to have package protection, you just don't write public, private, or protected. And you get package protection by default. So what does this do? If you have a class or a variable with package protection, then it's visible to all the other classes in the same package. But not to anything outside the package. And let me be clear when I say something is not outside the package, when I say something is outside the package, that means it's outside the directory where the package is stored. So again, as far as Java is concerned, stuff being together in a package means that the class files are together in a directory. Yes? If you have files inside a directory, but they don't say package list on the top, you're probably not going to be able to compile them properly, or you're not going to be able to compile them to link with the rest of the code properly. So this is going to solve a problem for us. Before we had package protection, we had to make the list nodes public, and we had to give them public fields so that the slist class could do things with the slist nodes. But now we have everything together in a package. We give everything package protection except the slist class. And now the slist can manipulate the slist nodes, but an application that's using the slist from outside the package cannot access those slist nodes at all, or even know that they exist. So that's one approach for question. Mm-hmm. Mm-hmm. Okay. So suppose that you have things that are not in a directory. Let's suppose they're just in your main directory. So you've got your root directory, and you've got a bunch of files in there. So basically, there is what you can think of as a root package. So if something is in the list directory, it's part of the list package. If something is just in the main directory where you're compiling, then you can think of that as being part of the root package. Like, since everything is in the root package, that pretty much means everything can see the package protected stuff in the root package. So if blah.java has package protection, then every class can still see it because it's in the root package. And every class is in the root package. So basically the idea is that the root dir is something that's on the class path, which means that it's part of the root package. So if you have a file in the root package and you give it package protection, you're not really protecting it in any way at all. For package protection to actually protect something, it has to be inside a subfolder. So I just told you that one way to deal with slists and encapsulate slist nodes better is to put them in a package and make the slist node class package protected. In Homework 4, we're going to do something slightly different. In Homework 4, we're going to work with dlists, and there's going to be a dlist node class that is public. It's not package protected. And the reason we do that is we want application programs to be able to hold onto a dlist. But we don't want application programs to be able to corrupt or change that dlist. We just want them to be able to hold onto it. And so the previous and next fields of a dlist node will still have package protection. So an application program cannot corrupt the dlist or change its invariance. So that's a nice compromise. You can have a dlist node class that's public. Applications can grab individual dlist nodes, but they can't change them because they can't read the fields of the dlist node. And so an application can't corrupt your dlist node or make its invariance break. But what an application can do is hop from node to node very quickly inside a list. So by the way, it's useful to know that every public class must be declared in a file named after the class. But if a file has package protection, you can actually put it in any .java file, say with another class. A package protected class doesn't have to be in a Java file named after itself, so long as the compiler can find it when you need to compile. So if we go up to the example I had a few minutes ago of the slist and slist node classes, I could have put the slist node class in the file slist.java instead of putting it in its own file. And the compiler is happy with that. Very important warning, you're going to want to remember this when you come to do programming, when you come to do homework 4. When you are compiling and running files in a package, you have to do it the right way or the compiler will not cooperate with you, and neither will the Java virtual machine. These things have to be done from outside the package. You have to do them from the root directory, meaning the root where all of your sub-packages are stored. And you do them as follows. When you want to compile, we write javac. I'm going to throw in a -g for the debugger just to get you used to doing that as a habit. But you have to write list/slist.java. What you cannot do is you cannot cd into the list directory and then compile slist.java. You have to be outside the list directory to compile the stuff in the list package. And you have to be outside the list directory to run it too, but the way you run it is a little different. You don't say / anymore. When you run a Java program, you have to actually use the same notation that's used inside Java programs. So we refer to slist not as list/slist. We refer to it as list.slist when we run the Java virtual machine. So a bit confusing, but you have to remember this, or you won't be able to run your programs or do homework for. Yeah, question. Mm-hmm. Can you not import what? Generally, no, you cannot import a package-protected class, no. Yes, the compiler will just complain that it can't find the class at all. And a few words about visibility as well. So we now know 4 different kinds of declarations for visibility. And so the declarations are: we can declare a variable public, protected. We can give it the default package protection by not declaring any keyword at all, or we can declare something private. So what do those 4 choices mean? They're essentially 4 different gradations of protection. And usually the ones that I get confused, and everyone gets confused, are the 2 middle ones. What's the difference between protected and package? Well, there's several different levels of visibility you can have. You can have, are things visible in the same package? Are things visible in a subclass? Are things visible everywhere? Well, things that are declared public are visible all three of these places, everywhere. Things that you declare as protected are package as well. And of course, they're visible in a subclass, because that's what protected means. If you give something package protection, it's visible in the same package, but it's not visible in subclasses outside the package. And lastly, private variables are not visible anywhere else except the class where you declare them. Any questions about that? Mm-hmm. It is impossible to inherit default class outside the package, yes. Yes. Mm-hmm. Is protected visible in objects? So this is always about objects, but the answer to the question depends on the class in which you're trying to access this object's variables. So if something is protected, you may have, like if a field is protected, but the object itself or the class itself is not protected, then you could have a completely outside class that has a reference to that object but cannot read that protected field. Mm-hmm. How do you keep the what protected? So how do you keep the fields protected in a class that's public? Just like this. So slist is public, and so that means any class that wants to can construct an slist object and hold on to it and call methods on it. But what they cannot do is they cannot read the head and size fields of that slist. Does that answer your question? Okay. Other questions? So to think about packages, let's talk about iterators a little bit. You've all been introduced to iterators by Project One, unless you haven't started Project One yet. So let's refresh ourselves. There is a standard interface, a standard Java interface called iterator in java.lang, which is just a way of promising that I'm going to have something that implements three different methods: hasNext, next, and part of this interface is a remove method. And the remove method is somewhat optional. When I say optional, I don't mean you don't have to provide an implementation. You do have to provide an implementation of remove, but it doesn't have to actually do anything. Usually if it doesn't do anything, it throws an exception, and we'll talk about exceptions next Wednesday. Now, I like to think of an iterator like a bookmark. The idea is that an iterator can be defined on many different data structures. So you can have an iterator over an slist. You can have an iterator over a run-length encoding. You can have an iterator over a tree or a hash table or all kinds of data structures we're going to learn this semester. And an iterator's job is to go through all of the items that are stored in a data structure and return each one once. But the idea is that you want to be able to have many iterators iterating through the data structure at the same time. And they should all be independent of each other. They should not interfere with each other. If I advance one iterator so it reads a bunch of items out of the data structure, the other iterators, like good bookmarks, stay where they are. And I can read them later. And most of you have figured out from the project that when you call next, for, say, the nth time on a particular iterator, that it should return the nth item in the sequence. And so you construct an iterator. The first time you call it, it returns the first item in the sequence. The second time you call it, it returns the second item. And so on, it returns every item once until it's returned all the items, and then it won't return them anymore. After that, subsequent calls to next just throw an exception. And again, we'll learn how to throw exceptions next Wednesday. Until then, you don't have to worry about it. I find this annoying, by the way. I would really prefer if the next method just returns null when you run out of things to iterate over. But the Java designers had different ideas than I do. In order to help you avoid triggering an exception, there is a hasNext method, which returns true if and only if there are more items to return. The usual convention is that you should always call hasNext before you call next. And if hasNext returns false, you don't call next because next will throw an exception. So hasNext is a warning, don't call me anymore. I am done giving you items. There's no more items. There's generally no way to reset an iterator automatically to the beginning of the data structure. You're supposed to just construct a new iterator when you want to start over at the beginning. Question? Yeah. No. So iterators are really supposed to be independent in the same way bookmarks are. If I have a bookmark in a book on page 237 and you have a bookmark, you should be able to read and move your bookmark through the book, and my bookmark will be in exactly the same place when I get back. And if anything's changed at all, I'll be very upset. So always think of the bookmark metaphor, where you have multiple people reading the same book. You just don't want anyone else's bookmark to affect your bookmark at all, ever. Well, if you do implement remove, then yes, that may mess up some of the other bookmarks. That's an exception to that rule. If you change the data structure, all bets are off for all the other iterators. So yeah, that's the thing about iterators. They're only guaranteed to be good until you change the data structure. Then some of them might be completely screwed up. Yeah. When you call next, it should return an item from the dlist or from whatever the data structure is. I think you're confusing the hasNext method with next pointers in a list. They kind of have nothing to do with each other, really, and it's just a coincidence that they have the same name. But please ask me that question after the class, because I can't give a simple answer. Most data structures that support iterators implement another interface in java.util called iterable. So in java.util, you have another Java interface called iterable, and this should be implemented by the thing that you want to iterate over. So for instance, suppose I have a data structure called ds, or a class called ds, which is a data structure. Then if I call ds.iterate, then that constructs an object called a ds iterator. which iterates over all of the items in the data structure DS. So again, the idea here is that DS implements the iterable class as a way of saying this data structure can have iterators that return all the items in that class, but it returns a different kind of class. A DS iterator is like a bookmark, but you can have many, many bookmarks on one data structure. Therefore, the DS iterator is a separate class that implements the iterator interface. Or in Project 1, run length encodings have an iterate method that produces a new run iterator object, which iterates over the run length encoding. One of the advantages of this is that Java has a built-in loop called a for each loop. I've taught you one kind of for each loop that iterates over an array. Well, there's another kind of built-in for each loop that iterates over the items in any data structure that has an iterator that implements the iterator class. That implements the iterable interface. And here's what the loop looks like. Let's suppose that L here is some data structure like an S list that implements iterable. Then we can iterate over all of the objects inside that data structure just like this. And if you want to know what this loop is doing, it's kind of equivalent to the following loop. What Java does is it automatically creates an iterator object, even though you don't see it, on your list. And then it just keeps calling hasNext, and as long as hasNext is true, it will pull up the next object, and do whatever the loop body is. And so when you write the loop on top, the for each loop, Java is creating a hidden iterator. You don't see it, you don't see the variable, but it's creating an iterator and iterating over your data structure with that. To make all of this more concrete, I have written out a full example of iterators over a list, which you'll find as sort of an appendix in the lecture notes. And that's all for today. Let me remind you again, please don't forget to attend the midterm. And I wish you all the best of luck with that. And thank you.